chemistry peeps, here is your explanation for 2.1.2, which talks about specific heat capacity, heat of fusion, and heat of vaporization. Okay, so this is the handout that's posted on Canvas right now, so let's talk about it. I gave you the curriculum, of course, and then here I need you to know the specific heat of water. I want you to click here on the handout to find out more about specific heat. For heat of vaporization of water, this is the standard amount. Those are joules because heat is measured in heat energy is measured in joules. And Khan Academy, please go and click on that. And then heat of fusion, which is basically melting, and for water it's 334. And here's the Chem Libre text that will help you even more with that. Enthalpy, the total kinetic and potential energy of a system at constant pressure, of course. And then the change in enthalpy is what we use the delta symbol, or the triangle means change. And that is the change in the heat of a system. So when you see change in enthalpy, it'll be a delta H. This is a great YouTube video with some practice problems, so please go there and work those, okay? I want you to also look at your reference tables. You will see on the front page, thermodynamic constants, heat of fusion of water, heat of vaporization of water, specific heat of water, the symbols that are used in the formulas, and the values that you use to plug in, okay? So let's get started. I'm going to work a few with you. So this one, the first few are on specific heat. So it says how many joules of heat energy are absorbed in raising the temperature of 10 grams of water from 5 degrees to 20 degrees Celsius. And so I just went ahead and told you in this first one, CP means specific heat, and the specific heat of water is 4.18. So you will have to remember that. Okay, so what's the first thing we do? We write down the formula. So Q equals mCp delta T, just like it's written up here in your curriculum. Now, M stands for mass, CP stands for specific heat, and delta T means the change in temperature. So in this case, it's asking how many joules of heat energy. So I know that that's what I'm looking for, is the Q. And then the next part, it gives us 10 grams. So M stands for mass, so 10 grams. And then CP, specific heat of water, we know is 4.18, and the change in temperature is going to be, here it is, so you say 20 minus 5 equals 15 degrees Celsius. Okay, always show your work, point out everything that you know in the problem, write the formula. Now all we have to do is fill it in. So Q equals mass times the specific heat of water times the change in temperature. Okay, and so when you multiply those straight across, you should come up with 627, and this is measured in joules. And right here, how many joules? That's what we were looking for. Okay, so the next one I want to work is on the next page, number 6. Okay, we're still doing specific heat on this one. So how many grams though? The reason I'm doing this one because these other 2 through 5 are all work the same. So this one's a little bit different. So you're already given the energy, and then it's asked, and then it gives you the temperature. Okay, so my equation is still the same. Mass times specific heat times the change in temperature. But in this case, I am given what Q is. which is 2,510 joules. Okay, and it did not give us mass, so it says here how many grams. So that's what we're looking for, is mass. Mass is measured in grams, and we are looking at the specific heat of water being 4.18, and the change in temperature being 30 minus 10 equals 20 degrees Celsius. Now all we have to do is plug it in. So we're given Q this time. So 2510 equals mass. Put the M because I don't know it yet. Okay, specific heat of water, 4.18 times the change in temperature, which is 20. Okay, and so when you get that, what you should see is 83.6, I believe. So 2510 equals M times 83.6, because that's what those two are multiplied together. Now you have to get M by itself, so you divide by 83.6 to get rid of it, but what you have to do to one side, you have to do to the other. So now when you divide those, you should get mass equals 30.02 grams. Okay. All right, and then I'm going to work number 7. What occurs, because I want a little bit more explanation here. So I'm going to talk about that one. So what occurs when the temperature of 10 grams of water is changed from that to that? So always write your formula first. Okay, and so now what do we know and what do we not know? Well, in this case, we do not know Q. Do we know mass? Yes, it is 10 grams. Our CP, specific heat, is going to be under the assumption that it's for water at 4.18 unless told otherwise. And then our change in temperature is 1, if you look at the 15.5 and 14.5, so 1 degree Celsius. So Q equals 10 times 4.18 times 1, which should give you 41.8 joules. And so what is really happening in this problem? So what occurs when the temperature is changed? The temperature went down, okay? And if the temperature went down, okay, that means it is exothermic, because that heat was released, okay? So I'm right, because temperature went down, okay? So that technically means that energy is lost. I hope that makes sense. So if the temperature went up, then we would assume that it's endothermic, okay? All right, so another set would be heat of vaporization, a different type of calculation, and the formula for this one is Q equals MH with a little v, heat of vaporization. So in this case, how many joules of heat are absorbed when 50 grams of water at 100 degrees Celsius are completely vaporized? So we're looking for joules of heat. We know mass is 50 grams. And the heat of vaporization of water, if you look at your reference tables, right there you will see that it's 2,260. So I'm just going to come over here and write this down, and that is joules per grams. And now all I have to do is plug it in. Mass times heat of vaporization. And so you should come up with 113,000. Now, just in case they decide to, scientific notation shows up, how would I change that to scientific notation since that's kind of a large number? So remember, you start over here, you move your decimal point over. So 1, 2, 3, 4, 5. So when you move it to the left, it's a positive exponent, and we counted to 5. Now, if I had moved it to the right, it would have been a negative exponent. Okay, so there it is in scientific notation. Okay. All right, the next one I'm going to do is number 11. A certain amount of liquid water required 17,000 joules of heat energy to completely vaporize it into gas. What is the mass of the liquid? So I'm looking for mass. Okay. So we're using our same equation. So Q equals M, H, and V. Okay. We're looking for Q. We know, I apologize, we are not looking for Q. Q was given to us. It's 17,000. So mass is what we're looking for. So what is our HV? It is, we are going to assume is 2260 because that's what it is for water. And if we're not told, that's what we go with. So Q, well, we know what Q is. 17,000 equals mass times 2260. To get mass by itself, divide, which do to one side, you got to do to the other. So mass, when you divide those, should equal 7.52, and we measure that in grams. Okay. All right. Now let's talk about heat of fusion. Okay. The equation for heat of fusion is Q equals M and then HF for heat of fusion. So in this one, what is the minimum amount of heat required to completely melt 20 grams of ice at its melting point? At its melting point. And that's basically what heat of fusion is melting. Okay, so what we are looking for is the heat, so that's our Q. We have been given our mass, which is 20 grams. So we don't know what should be our heat of fusion. Okay, and in this case, since it's not given to us, then we're going to come over here and look at our reference tables and see that our heat of fusion of water is 334, and that's what we're going to use. Now plug it in. Q equals 20 times 334. So Q equals, if you multiply those, you should come up with 6,680 joules. Okay, last one. What is the total number of joules required to completely melt 65 grams of water? Okay, so again, write out your equation. We're looking for Q. Our mass is 65, and our heat of fusion was going to be our standard 334. Plug it in. 65 multiplied by 334, and so Q equals, correct me if I'm wrong, but that's what I got, and I calculated 21,710 joules. I hope this has been helpful. Let me know if you have any questions.